Griffin, I feel like you come in just to yell that and then leave. And as I said that, there was a possibility you may have already left. There we go. All right. I'm going to get started with this, mainly because I need to get moving with this information, and I have a lot of things to get done today. Let's see if I can do this. Will this move at all? Yeah, it's moved a bit, kinda. Unfortunately, this is the best that I can do in terms of dealing with these quizizz problems. If you want a copy of these quizizz questions, there is a PDF in the description, a link to the PDF in the description. Yeah. I'm going to paste a link to that as well. That should work. Let's see if I click that. Will it take me directly there? Okay. I am also going to drop a link for this guy's website, Matt Bogner. Let's drop that into the chat, and the specific whatchamacallit, link for the t-test. I'm going to drop that in there as well. I'll put those into the description after the fact. But I am going to be go to those problems. I'm sorry, to that website in order to do a couple of these problems. That's if you don't have a graphing calculator. If you do have a graphing calculator, good for you. You're in good shape for that. Yep, I'm back. That was terrible. Oh my gosh. I do not know what that was. But I should be back, I hope. This has been a disastrous day in terms of live streaming. There we go. Now back. Okay. Looks like I got no one with me here. That's okay. We'll deal with this in the time being. Or we'll deal with this. Okay, I don't know what I'm doing anymore with this. What a day. What a day. Okay. Again, I apologize. It's just been a hectic day with technology. Again, I'll put the timestamps into the description when the time shows up, and we'll see how this goes. So, in the meantime, let's just go through these one at a time. And we'll see where this kind of leads us. So I'm looking at number 1. A medical assistant sampled the blood pressure of 20 randomly selected patients with high blood pressure before and after they receive a dose of a new medicine. Which hypothesis test should be run? Now, in terms of this problem, you do not have a population standard deviation. This is quantitative data, meaning, well, in order to use a z-test, you have to have the population standard deviation, but you do not have the population standard deviation. This has to be a t-test. Now, based on the 4 choices that they gave you, yes, it has to be a t-test, but which one? Keep in mind that they are going to be collecting data on people's blood pressure both before and after they receive the new dose of medicine. The thing that you have to know is that from one sample to the next, the results are not going to be independent. They're not. You're going to be looking probably at the difference between the two, both before and after. But the reason why they're not independent is because it's the same patient receiving that medicine. You have to do a paired t-test here. Basically, you find the difference between the individual patient from before and after. You're going to find 20 of them. Yeah, the answer has to be A. Let's go down to number 2. If I'm looking at number 2, a researcher gave one group of people an active drug and gave a different group of people an inactive placebo. So you get 2 different groups receiving 2 different treatments. Which test should he run to determine the efficacy of the active drug? Which hypothesis test should he run? For this particular problem, again, you don't have the population standard deviation. And since you don't have the population standard deviation, you have to do a t-test. I mean, they don't tell you what the population standard deviation is at all. In this particular instance, which t-test you're going to do? Well, these are 2 independent groups. These are 2 independent groups. One group's results does not affect the other group's results. The reason, ultimately, this is going to be a 2-sample t-test. 1 sample taken with the drug, 1 sample taken with the placebo. The answer is B. Going down to number 3. The fire department of a small city wants to know if the proportion of homes having at least 1 smoke detector is still 90%. They take a sample of 100 homes and check if they have working smoke detectors. Which hypothesis test should he run? Now, thinking about the type of data that you have, proportions. You're talking about proportions. Now, let me get a little piece of paper going on here. And let me bring the camera down ever so slightly. Here we go. There was a chart that I had given you way back when. And in this chart, it initially just asked you what type of data you had. What type of data do you have? And it's split. Move that down a little bit. There we go. It's split between quantitative and categorical. Split between quantitative and categorical. If you had categorical, now this is a little backwards from the one that I originally gave you, but the point still stands. If you're dealing with categorical, you're dealing with proportions. If you're dealing with categorical, you're dealing with proportions. And it doesn't matter if it's 1 sample or 2 sample, it doesn't matter. If you're dealing with proportions, you are ultimately going to do some form of a z-test. It didn't matter what other pieces of data you had. Obviously, you could do intervals, test, whatever the heck you want here. If you have quantitative data, I'll zoom back out just a little bit here. If you have quantitative data, it really depended on whether or not you had sigma or if you don't have sigma. Sigma being the population standard deviation. If you had sigma, you would still be running a z-test. One sample, two sample, interval doesn't matter. But if you don't have sigma, then you would have to be resorting to a t-test. Now for this problem, for number 3, you are dealing with categorical data, meaning you have proportions. You don't have means here. I'll go back up to the problem itself. There we go. Go back up to the problem itself. You're dealing with proportions. Automatically, your answer is D. You can't do a t-test here. Going down to number 4. There we go. We use a paired t-test for 18 students at Bethel AP Statistics class, in the class. And 18 students in the whatever class that is, to see if one teacher has a higher score on the AP exam than another. We get a p-value of 0.14. What should we conclude? This is not a proper paired t-test. The reason why it is invalid is because you have to go back to your assumptions and conditions. Where's your randomness? This is not a random sample. You're basically taking a census of one class and a census of the other class. You can't conclude anything. Number 5. It says 9 randomly sampled students were asked how many hours of TV they watched last week. X bar was 3.5 hours. S, the sample standard deviation, was 4. For 95% and 8 degrees of freedom, they give you T star. Don't worry about that. The stem plot was somewhat skewed to the right. All right, somewhat skewed to the right. That would be the nearly normal condition that they're going for. And there were no outliers. What is the 95% confidence interval for M? It says, what is M? The number of hours of TV, I'm assuming? Whatever M is. Well, let me go back down here. Oh, no. See, this is why I tried to do a camera before that could switch positions easily so I didn't have to do something like this, but whatever. Your T interval. X bar plus or minus T star times S over the square root of N. This would be for a T interval. With a T, either be interval or test, you don't have sigma. You don't have the population standard deviation. As a result, you got to use S. Now in this problem, they told you that 3.5 was X bar, that is. They told you your T star was 2.3 times your standard deviation over the square root of the sample size. Sample size was 9. Now in the responses, they gave you one that looked like this with a 3 on the bottom. That was your square root of 9. The answer to number 5 was D. The answer to number 5 was D. Let's back at number 6. Zoom back in just a little bit. No, that's way too much. Nope. I could do this in one shot. There we go. Back at number 6. Number 6. A student who wanted to assess the average time spent studying for the most recent exam taken in class. He asked the first 45 students who came into the class how much time they spent and recorded the values. He then used this information to calculate a 95% confidence interval for the mean time spent by all students. Was this an appropriate use of the T procedure for the confidence interval? No. No, it was not. He surveyed the first 45 that came into the class. The answer is D. Moving on. Number 7. Each of 16 milk cows were fed 2 diets in random order. Milk production was measured for each of the cows while being fed each of the 2 diets so that 32 milk production values were recorded. Matched pairs, one sample T procedures will be used for inferences. How many degrees of freedom does the applicable T distribute to n minus 1? Your n value for this problem is 16. Yes, I know that there are 32 milk production values, But because you're doing a matched paired t-test, you would find the difference between the individual count for both before and after. Or it says 2 diets in a random order, diet 1 minus diet 2, or some junk like that. But since the sample size is 16, the answer is 15. Degrees of freedom is equal to n minus 1. The answer is C. Number 8. A tire manufacturer claims that one particular type of tire will last at least 50,000 miles. A group of angry customers does not believe this is so. They took a sample of 14 tires to test if the mean mileage of the tires is really less than 50,000. If 0.01 less than p-value less than 0.02, meaning your p-value is between 0.01 and 0.02, what decision should be made if testing with the alpha level at 0.05? Your p-value, according to this, is between 0.01 and 0.02. It's lower than 0.05. If the p is low, the home must go. You are going to reject, which narrows your choices to either A or B. You're definitely going to reject. But what do we conclude? The tire manufacturer claims that the tires will last at least 50,000 miles. Your null hypothesis is mu equal to 50,000. The alternate is being less than 50,000, meaning they're trying to show evidence against the 50,000 miles. If you're going to reject your null hypothesis, you are concluding that the 50,000 mile claim is wrong. The answer to number 8 is actually A. You're rejecting and concluding that the tires were not performing as they claimed. Talk about number 9. One reason for using a standard normal curve to find critical values when calculating the confidence level, blah, 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 blah. Again, ultimately it comes down to that chart that I showed you. Do you have the population standard deviation? The answer to number 9 is B. Z requires that you know the population standard deviation. That's what it comes down to. Number 10. Now, number 10 takes a little bit of finessing. Which of the following would not decrease the width of a confidence interval? Which would not decrease the width? Meaning, perhaps it would increase the width. 1, increase the sample size. If you increase the sample size, your margin of error is going to shrink. Whenever you increase the sample size, n is on the bottom of that fraction, square rooted, it's going to decrease the margin of error. So it would decrease it. Number 2, decrease the degrees of freedom. Now, the degrees of freedom is linked directly to sample size. Degrees of freedom is equal to n minus 1. If you are decreasing the degrees of freedom, you are decreasing the sample size. If you decrease the sample size, you are spreading out your margin of error. It's a larger margin of error, basically. 2 is correct. Let's look at the third statement. Decrease the confidence level. Either your Z star or T star, whatever the heck you end up doing. Pretty much T star if you're doing degrees of freedom. But if you decrease your confidence, you are actually shrinking the confidence level. Or not the confidence level. You are shrinking the size of the interval. Think about the concept of being 100% confident. The only way that you are 100% confident is if your interval contains everything. From 0% to 100% or some junk like that. The higher the percentage, the wider the interval, because that increases the T star. So the only one that would not decrease it. Oh, by the way, for the third statement, it says decrease the confidence level. If you decrease the confidence level, you actually shrink the interval. The only one that's correct is 2. The answer is B. The answer is B. For number 11, this problem was the only one on the whole quizzes where the actual correct answer was not correct. I went back and I fixed it for your scores, not on the actual quizzes. I'll have to fix it for the quizzes in the future for other classes, but not for you. For you, I went through and I checked to see what answer you picked, and if you picked the correct answer, then I fixed your score. Otherwise, they stayed the same. This problem is talking about a confidence interval that you constructed. And you found a confidence interval from a simple random sample, and the interval was from 122 to 138. Which of the following is true? The answer that quizizz had selected for itself, which was wrong, quizizz picked D, whoever made this question originally, and that's wrong. If the procedure were repeated many times, 95% of the time, the population would be between those two intervals, or between those two numbers? No. 95% of the time, and this is what most people ended up picking, 95% of the time, the interval would just capture or contain the population mean. You don't know if your interval actually did it. You can only say that you're 95% confident. The answer, as a lot of people picked, the answer was C. The answer should have been C. Number 12. Definition of p-value. P-value definition comes down to C again. The probability of obtaining the results if the null hypothesis is true. That's what a p-value is. That's the definition that I've always given you. Assuming that the null hypothesis is true, what are the chances that you get those sampled results? The chances are the p-value that you got. That's what the definition of the p-value actually is. Number 13. A researcher plans to conduct a test of hypotheses at the alpha equal 0.01 significance level. She designs her study to have a power of 0.9. Now, this is one of those situations where they give you the power, which in this case you could calculate beta, but that's not what the question's asking. She designs to have a power of 0.9 at a particular alternative value of the parameter of interest. The probability that the researcher will commit a type 1 error is, the chances of making a type 1 error are whatever you set your alpha level to. Your alpha level in this case is 0.01. If you change the alpha level, that inherently changes the beta, which would change the power, yes, but this is all they're asking for. Chances of making a type 1 error. Answer's A. Number 14. Now, number 14, certain definition. 900 men who practice yoga are surveyed to determine if they report low stress levels. The CFO of the surveying company is concerned about the cost associated with surveying 900 men, so she suggests sampling 100 men. Assuming the sample proportion does not change, what effect on the width of the confidence interval would occur if they were to serve 100 instead of 900? Bring this down here. What it would do is this. Here's the t interval right here. I wrote this for a previous problem. Doesn't matter if it's a t interval, doesn't matter if it's a z interval, doesn't matter if it's proportions, doesn't matter if it's means, the sample size is always in the bottom of the fraction, and it always has a square root around it. They're talking about 100 versus 900. Well, if it's s over the square root of 100 versus s over the square root of 900, this would be s over 10 versus s over... Well, this would give you a weird... Wait, is 900 perfect square? I think 900 is a perfect square. Yeah, what am I losing my mind for? It is a perfect square. Could have figured that out. Or you could have taken the 100 out. Or not the 100, the 9. There we go. Regardless, for number 14, the answer is B. The width of the interval based on 100 would be 3 times wider than that of the one with 900. It would be 3 times wider because the larger the sample size, the smaller the margin of error. So the answer to that particular problem should have been B. Let's go to number 15. Now, number 15, you could answer it in a number of different ways. You could use a graphing calculator. In lieu of a graphing calculator, you may have to, if you don't have one, you may have to calculate it by hand, or you could use this website that I'm about to show you. Jimmy's interested in comparing the fitness level of the members of his gym to the levels at a competing gym. He randomly selected 125 members of his gym and found 75 passed the fitness test, whereas 70 out of 95 at the other gym passed. 2 independent samples. Now, we're dealing with proportions, so this would be a z-star that you would need for this problem if you're going to do it by hand. Which interval estimates with 96% confidence the difference in proportion of members in Jimmy's gym who can pass the test and the proportion of the other gym who can pass? So, if I'm going to go down here, I'll do this one by hand first. What you would need is the following formula. Since you are unaware as to what the population proportion would be, this is the way the sample error would be calculated. The sample error would be calculated slightly differently depending on if you were dealing with a test versus an interval. For the test, you're assuming the population proportion. For the interval, you're attempting to capture the population proportion. But if you were calculating it like this, this is the process that you would have to go through. Now, if you did have a calculator, I set my calculator up. No, I erased it. All right, I'll have to set my calculator up again. Chapow. There we go. I'm going to have to do some calculations. Again, you'd have to write this out by hand. I'll do this kind of by hand first, and then I'll show you on the calculator, and then I'll show you on the website. I'll show you all 3. But the first one, 75 divided by 125, I'm going to store that to the first sample. 70 divided by 95, I'm going to store that to the second sample. And if you notice, I'm storing them to letters so that I don't have to retype any of the numbers. Now, inverse norm, obviously, you would need, either need a graphing calculator or you would need ways of doing that. There are different calculators that you can use online and whatnot, but unfortunately, this is the best way to do it. 96% confidence means that there's 2% on both sides that you're missing, meaning you got to do inverse norm 0.98. I'm going to store that to z so that I have my z-star. Let's see what this calculation should be. So A is the first sample, B is the second sample, and Z is my z-star for 96% confidence. If I were to do, let's do the margin of error first. Square root of A times 1 minus A divided by the sample size, which was 125, plus, because this is the formula, B, parentheses 1 minus B, close parentheses divided by the sample size of 95. This would be the sample error. Multiply that by the z-star. This is my margin of error. And then if I were to do the difference between the 2 samples, well, let me store this first. Let me store this into M for margin of error. There we go. Plus the margin of error. Do it again, minus the margin of error. Doing it by hand got me negative 0.266. negative 0.008 it rounds to, but I'll go 7.6. Yeah, 2261. Here we go. That's what the interval should be, and it is. The answer to this problem is C. The answer should be C. That's one way of doing the problem. If you had a graphing calculator, which a bunch of you do have them, you would have to go to 2 prop z int and just simply type in the proper ratios, 96% confidence. There it is. The exact same interval, the one that we did by hand. Now, again, if you, unfortunately, were just using a website, let's say, let me bring this up over here. I have, again, in the description, I'll zoom back out a little bit. Oh, Kyle said hello. Come on, zoom out. Whatever, that works. The website that I have for you is this one by Matt Bogner. Zoom in a little bit here. Come on, camera. Do your thing. It's not doing its thing. There we go. So the one from Matt Bogner, if you go to Matt Bogner's website, and then you scroll down to inference for the difference between proportions. There it is. Inference for p sub 1 minus p sub 2. It'll bring you here. And you can type in the sample size and the proportion. You'd actually have to type it in like that. So, the first sample size was 125. The first proportion was 0.6. Actually, you know what? Can I just type it in like that? Let me see if I can type it in like this. Let me see if I can type it in as, what was it, 75? Let me double check here. Yeah, it was 75 out of 125. So, let's see if that actually did work. No, we'll see. I'll go back and double check. And then the other sample size was 95. And it was 70 out of 95. Ah, would you look at that? It did work. So you can type it in like that. Now, this website's really nice because they don't really ask for much beyond this to calculate the confidence interval. But if you wanted to do the test, you would have to do something. Unfortunately, for this website, they only give you these choices in terms of percent confidence. They only give you these choices. Now, 95% is very close to 96%. If you were going to go to 96%, you would be a little bit more confident. That would increase the size of your interval ever so slightly. And if you look at the answer, the interval that they give you for 95%, you can see how close that is to the interval that we got for 96%. Unfortunately, that's the closest that we could potentially get for this problem. Yay. In fact, choice B, if I went back to the problem itself, choice B would be 95%. That would be what you would get with the 95%. So that website did give you the 95% one. But if you're going to go 96%, that one would be slightly wider if you're going to use the context clues. Number 16. Oh, again, just for reference, the answer was C. Number 16. A nutritionist claims U.S. children drink an average of less than 2 glasses of milk per day. Who drinks more than 1? My gosh. Based on a simple random sample of 30, a p-value of the null and alternative is 0.0015. What's the correct interpretation of the p-value? Again, definition of p-value. The probability that you would see such sampled results if the null hypothesis were true. The only one that hits that is D. D is the only one that hits that. 0.15% of all samples would it should say produce a test statistic at least as extreme as ours, if the null hypothesis is true. That's the same way of putting it. But that's the definition of a p-value. 0.15% of all samples. There's a 0.15% chance that we would see such sampled results. 17. Now, 17 does require a t-test. I'm going to do that on the calculator, and I'm going to do it on Matt Bogner's website in a moment. The process of making cough drops yields drops with varying amounts of an active ingredient. It is claimed that the average amount of this ingredient per tablet is at least 400 milligrams. We test a random sample of 90. The mean content of the active ingredient for the sample is 396.8 with a standard deviation of 31. That standard deviation is sample. What is the approximate p-value for the appropriate test? That's the t-test. You need to do a t-test for this particular problem. If you were going to use the calculator, if you had a t-test readily available. Of course, if you had to do this on free response, you would check, you would write out your null and your alternative, you would do the assumptions, conditions, but they actually just want you to run the test and get the p-value. That's why it's a multiple choice question. They claim 400 milligrams. You got a sample of 396.8 with a standard deviation of 31 and a sample size of 90. Now they say at least 400, which means the alternative is less than. And if you were to calculate that, you would get a p-value of 0.165, which is the answer. The answer is C. Now let's pretend for a moment that you did not have, again, a graphing calculator. How would you go about doing this? You would have to go back to Matt Bogner's website. On Matt Bogner's website, we scroll to inferences from mu. Doesn't matter, updated beta, doesn't matter. Not. Inferences from mu. The sample size, if I can actually type this in, the sample size was 90. The X bar was 396.8. And they give you a choice for sample or population. This is a sample, so it'll automatically do a t-test. 31. If now nothing pops up, you can't do anything, just hit enter. It gives you a confidence interval, but that's not what we want. Null hypothesis. This website's a little weird right now because I'm zoomed in a bit, but I have to change. Ah, come on, you. I have to change this alternate. Let me change it right here. No, why aren't you working? It's not letting me. Let me refresh this page. This is what I get for using the beta version. Sample size 396.8. 31 for the sample standard deviation. There we go. Use less than 400. I'll show you in a moment. There we go. Come back here, you. There we go. Now, if you look down, they do give you that p-value at 0.165. This is probably the best website that I've seen in order to do stuff like this. I will also point out that Matt Bogner also has an app that you could use. I should review that app with you guys at some point. Maybe I'll recommend it, and I'll put a link in the description, or in the Google Classroom or some junk like that. But that's what this thing does. What the heck? Last question. Come on. Why isn't this working? Boom. There we go. Last question. Number 18. A major department store wants to compare the mean number of customers an employee can process per hour using 2 scanning systems. There are 2 independent scanning systems. 100 employees are randomly selected and then randomly assigned to one of the new systems. Each group has been trained on one scanning system or the other. The number of customers processed per hour is recorded. Which test is most appropriate for this situation? Now, for this particular problem, this is definitely 2 sample. This is definitely two sample. They're two independent groups. Yes, there's 100 employees randomly selected. They're assigned to one of two systems, either the system 1 or system 2, whatever the heck it wants to do. The old system, the new system, I don't know. But it's definitely two sample. Now, the data that they're collecting, and I highlighted it right there, the number of customers processed in 1 hour. This is quantitative data. You are not dealing with proportions here. And it is highly unlikely that you have the population standard deviation. As a result, number 18 should be B. This is a two sample t-test. It is quantitative data. You don't have the population standard deviation. I'm going to have timestamps in the description. I'm going to have timestamps in the description when I finish this up. And I will put a reminder in the Google Classroom. That is all.